Okay, math models, this will be your last packet on EOC review. I'm just going to work through a couple and show you a couple of tricks on the calculator. First thing, when we're talking about systems of equations, that's when you graph or you're looking at two equations at the same time and you're trying to see what the solution would be. That's what point they have in common. And there's three options. First off, the lines are going to intersect and they have one point in common. That is the solution. If the lines are parallel, they have no common point, so there is no solution. And then the lines are the exact same line when you graph them. They line up on top of each other. That would be infinite solutions. Okay, so I'm going to look at number 3 over here because in order to use our calculator to find the solution to the system, we need to get y by itself for both equations. So I'm going to look at number 3, and the first equation already has y by itself, so I need to take the second equation and solve for y. So first thing I'm going to do is subtract 2x on both sides of the equation. So that's going to give me negative y equals negative 2x minus 3. And then I can divide everything by negative 1, and so my equation is going to be y equals positive 2x plus 3. Okay, so I'm going to switch over here to my calculator and I'm going to graph these two equations, 2x minus 5 and 2x plus 3. Okay, so I've gone into y equals on my calculator and I've put 2x minus 5 into y1 and 2x plus 3 into y2. Now I'm going to hit graph. And you should see your two equations come up. Notice that these lines are parallel. One thing that I would know that they were parallel from looking at the equations is that they both had a 2 to start with. It was 2x for both equations. And remember that first number is the m, which represents the slope. Since the slopes are the same, the lines are parallel. So I can tell that these lines are never going to intersect. You can also go to the table by hitting second graph, and you would be looking for where the y1 values equaled the y2 values. And I could scroll up and down in this table and I'm never going to have any that are the same because these lines are parallel. So going back to my paper, since I know that these lines are parallel, that means that there is no solution to this system. That means that they never intersect, they have no point in common. So that's no solution. So now I'm going to jump to number 6, one of the word problems, so that we can practice writing the equation for a system of equations, and then I can show you how to use the calculator to solve this one as well. So it says that a juice bar has two sizes of containers, a 12-ounce and a 16-ounce cup. One Saturday they sold a total of 166 drinks and used 2,248 ounces of juice. So I'm going to start with writing an equation for the number of drinks that they sold. And I'm going to say that our 12-ounce cup, I'm going to call that X, and my 16-ounce cup, I'm going to call Y. So I know that X plus Y equals 166. On that day, the two added together to equal 166. And then I want to write an equation for the number of ounces. So my 12-ounce cup is 12x plus my 16-ounce cup is 16y, and they told me that they sold a total of 2,248 ounces. Okay, so now I have two equations with both the same variables, x and y. I want to use my calculator to find out what values are the solutions to this system, what x and y value will make both of these equations the same. So in order to do that, I need to get y by itself for both equations. So for the first one, all I have to do is move the x over. So that's going to become y equals negative x plus 166. The second equation I'm going to do in two steps. I'm going to write y equals, I would move my 12x to the other side and it would become a negative 12x plus the 2248 that was already there. Then I would have to divide everything by the 16 that was multiplied by the y. And I'm going to let my calculator do the work for me so that I don't have to divide everything out. So I'm going to pause and type this into my calculator, and then we'll go from there. Okay, so you can see that in y1 I've typed negative x plus 166, and in y2 I've typed parenthesis negative 12x plus 2248 all divided by 16. I could have gone through and divided everything by 16 in that second equation, but if I don't have to, then don't do it. We're going to let our calculator do it for us. So once you have those in y equals, I'm going to hit graph. Because these numbers are so big, we're probably not going to see the graph right away. So I know that my calculator is done graphing because the little thinking bar has gone away that was in the corner. So what I'm going to do is hit zoom 3, enter. And that's going to zoom out on my graph. And my calculator's thinking about it. And it's done. I still can't see anything. So I'm going to do zoom 3, enter again. So now I can see my two functions here. They intersect somewhere in quadrant 1. So instead of me trying to guess and figure out what these ordered pairs are, I'm going to let my calculator do the work. So I'm going to hit second trace, and I want to find the intersection of these two graphs. So I'm going to hit 5. Your calculator is going to ask you 3 questions. It's going to say first curve, second curve, and guess. They want to know what 2 equations do you want to find the intersection for, and where do you think it is. Since we only have 2 equations here, you can go ahead and hit enter, enter, enter. Enter 3 times and it'll find the intersection for you. So this is saying that the solution to this system is 102, 64. So I want to go back to my paper and translate that for this problem. Okay, so for this problem, we're saying that the solution is the ordered pair 102, 64. So for those 2 equations that we found out, this is the ordered pair that works for both of those equations. I could also go to my table and see that these would have the same y value in y1 and y2. So back to what we started with, though, is we said that our 12-ounce cup was our x. Okay, so that's 102. And we said that our 16-ounce cup was our y, and so that's our 64 here. So we're saying that for this to work for these 2 equations, we had to sell 102 12-ounce cups and 64 16-ounce cups. Well, for this problem, they just wanted to know how many 16-ounce cups we sold, and that was 64. Okay, so you can use your calculator to graph the functions and then find their intersection. That is the solution to the system. Okay, now I'm going to jump to page 47 talking about domain and range. So one thing to remember is that x goes with the domain and y goes with the range. So when I'm looking at a graph of a function and they want to know what the domain is, they want to know what are the possible x values for this graph, and then the range is what are the possible y values. So I'm going to start with the domain, and I always like to draw a line the farthest left that the graph goes and the farthest right that the graph goes. Okay, I want to look in between these 2 places. This is my domain. So I know that my graph goes all the way to -5 on the left, and it actually equals -5 since it has that solid circle there. And then on the right hand side it goes up to 9 but does not include 9, okay, because it's an open circle. Okay, so when we're writing that in interval notation, I'm going to go ahead and write my numbers down. -5, +9, I need an x in the middle. And then we're going to put some inequality symbols here to demonstrate what the domain can be. So let's look on the right hand side, x and 9. So x goes up to 9, so that means it can be less than 9. It's not equal to 9, but it's anything less than 9. Okay, then on the right hand side it goes up to -5, so it's numbers that are greater than -5 or equal to. So that greater than symbol actually opens up to the x because that's the number that's bigger. So what this tells me is that the x's are between -5 and 9 and can equal -5. Okay, now what I want to look at is the range. So the range has to do with the y's, so that's from the bottom of the graph to the top of the graph. So I'm going to go as far down as the graph goes and as far up the very highest point. And this is the range of my graph. Okay, so the lowest point on my graph, it looks like, is -3, and the highest point on my graph is 6. Then I'm going to put a y in the middle. Okay, so because the lowest for this graph is -3, and it actually does equal -3, I could put a solid circle down there. There's not one, but I could draw one. Since it does equal -3, then I'm going to put a less than or equal to. That means that the y's are actually greater than or equal to -3. Okay, and then it goes all the way up to 6, and it actually equals 6. So the y's are less than or equal to 6. So this is saying that y's are between -3 and 6, and they're actually equal to those values. Okay, this next page is asking you to kind of talk about the changes in a graph from the parent function to the different equations that they have listed, and to talk about if it's wider or narrower than the parent function. And one thing that the directions say up here is to leave out any negative signs. All the negative sign does is flip the parabola over. So when I'm going to type this equation into y equals, I'm just going to put a positive x squared, whatever the number is, okay? So when we're talking about if a graph is wider or narrower than the parent function, that's just the number in front of x squared. That's the only number that matters, okay? Everything else has to do with a shift or a reflection for the graph. So in my y1, I'm going to type x squared, which is the parent function. And then I'm going to just do part A with you. I'm going to put 5x squared. Like I said, the -2 isn't doing anything. That's a shift up or down, so that doesn't have to do with the width of the graph. And because my parent function is in y1, I'm going to go up to y1, and in front of y1 there's a line, and you can hit enter one. So I hit zoom 6, and it took me back to the normal window. The bold line is my parent function x squared. The skinny line is 5x squared, or the thinner line, and it actually is a narrower graph. So for this problem, it was asking us to write whether the graph is narrower or wider than the parent function. So A, the answer is narrower. So all you have to do is graph each one of these with the parent function. I would leave off any of the negative signs in front of the equation, and then the plus or minus number at the end isn't going to do anything either. That will determine which ones are narrower or wider. Then in part 2, you're just going to list them in order from the widest graph to the narrowest graph. Then on the very last page, you're looking at translations of these graphs. You're trying to see if it was shifted up, down, left, or right. So I would graph parabola A in y1, parabola B in y2, and you can make one bold or the other. And then you're just going to write down what happened. So let me go ahead and type these into y equals, and then we'll look at the graph. Okay, so I've put parabola A into y1, and I've made it bold, and parabola B into y2. I'm going to hit graph. So there's my parabola A, there's my parabola B. So I can tell that parabola B has been shifted down. So I'm going to write this as a shift down. And you can count how many spaces. And I know that this is 5 spaces. Okay, the plus or minus number at the end of the equation is actually going to tell you a shift up or down. So that should help you answer some of the questions on this page as well.